All right, so we're looking here today at Kinematics 2 and Physics Classroom. And there's a couple of things that I've noticed a lot of folks struggling with. And that first one that they seem to bump up against is this question right here. Make sure to remember when you're doing this to just remember that a lot of times this can be a negative direction, and so sometimes when you get an average velocity or an average speed or the distance moved, just bear in mind you're going to be wanting to think about those negatives, because in fact it wants you to use a positive or negative sign. So when we deal with average speed, of course it wouldn't have a positive. You would just need to think about the total distance that he traveled and then his total time. Total distance for speed, total distance would include going down to here, back up to here, and then back down to here. So you remember you would need to add up that plus that because he's traveling down and back, down and back. Now velocity is just going to be displacement, and so velocity, wow, that'll take forever. Velocity would basically be if he started at 14 and then he ends at that would be 7, so the displacement would be -7. I went ahead and erased that so that I could make that a little bit more clear. He started here and then went ended up down here at, it's not 7, it's 6. So the displacement would be from 14 down to 6. So the displacement on this one would be -8. And that's something that I see some mistakes being made here. The next mistake that I notice, not mistake, but the next thing that I notice folks struggling with is this one here that wants to know how fast is he walking at these times. Well, the thing you need to realize is since slope is equal to speed on this, whatever the slope is through here, you can know his speed. So at 1 second, at 2 seconds, at 3 seconds, at 4 seconds, the velocity is always the same throughout this. So when it says, well, how fast is he walking at 2.3 seconds, it's basically saying, what is the slope in that time there? Because he's going the same speed. Likewise, how fast is he walking at 7.8 seconds? That would be something like right here. And it's saying, well, what is the slope there? How fast is he traveling at this point in time? So a lot of times people try to use this as part of the calculation, and that's just not the case. Thanks. I hope that helps. Sorry for the clunky nature of these graphics, but we should be good. Have a great day.